not much to be said about that. Let's see if I can do this right. There we go. Wanted to talk about, supply chain issues. Supply chain issues pretty much are sort of the driver behind things like SBOMs and a lot of other, technologies and regulations, especially the executive order. I'm in health, so there's a lot of FDA regulations. If you think the executive mandate or whatever is nothing compared to the FDA regulations. On top of all the SBOM stuff, they regulate quality, for example, which you guys are familiar with because I demanded it. But quality basically says something like, is the repo you're pulling from abandonware? Has it had any pull requests? That type of stuff. So supply chain attacks, they are increasing in frequency. That's a statistical fact, if you can believe, what you read. They do cost money, but on the other side of things, so they cost money, they erode confidence, they cost jobs, regulation madness. I'm going to talk a lot about regulation madness during the talk. But ironically, they also create jobs. Half the people downstairs, have a job because SBOM suddenly became a thing that everyone needed. And overnight, there were like a dozen, Silicon Valley had a dozen new SBOM, companies. And companies that didn't do things related to SBOM suddenly, were advertising that they did. And qualitatively, when you look at, an SBOM, they come in all different shapes and sizes. Some of them are pretty good, some of them aren't. But the thing about an SBOM is, and I really didn't intend to talk much about SBOMs. I kind of left it off the title intentionally. But the thing about SBOMs is they're really just a snapshot in time of a source composition analysis scan. So if you, for example, if you know the components in your code because you've done a source composition analysis scan, and assuming the fidelity is pretty good, you just take a snapshot of it. You don't have to tell your customers what vulnerabilities are there. You don't have to tell them what the licenses are there. You just have to tell them things like that come in the Perl. That's the project URL, so you're telling them, this is the name of the component, this is the version, this is where it comes from. You can go to the NVD and figure out the issues themselves. But it created jobs, it created companies. Regulation madness. Regulations also create jobs. Whether that's a good or a bad thing, it's a fact. And the company I work in there might be as many people involved in regulation stuff as there are like engineers. So it's a big thing. This image, by the way, is from the Apollo 18 launch, which they made a movie about it. Didn't go very well at one point, and then they fixed it. And let's see if I can manage this right. I did. Okay. So one of the things I want to talk about when I talk about supply chain attacks is there's no such thing as a supply chain attack is an umbrella term that relates to multiple types of attacks. Such as, and I don't actually mention it in the talk because I pulled the slide because of time, but CI/CD, continuous integration, such as Jenkins, that's something you have to worry about. If you're, Jenkins is your Jenkins or Azure DevOps or GitHub. They're all going to be used to build automatically, and we always trust them, right? We trust them the way we trust repos. And what I'm going to talk about here is that, trust is not a good thing. When we go grab our code, when I do a pip install requests, right, I trust that it's going to bring in the request, library, module, and all its transitive dependencies, and I just intrinsically trust it. I shouldn't, but I do. So we'll talk about that as well. And so knowing what's in your code is supposed to help you guard against these issues, but it doesn't necessarily do that. And we'll go into why shortly, but a lot of it has to do with the type of detection method and the fact that there may not be a magic bullet when it comes to detection methods. And so if there's no magic bullet, if there's no one way to accomplish what it is you're trying to accomplish, what do you do? And you have to get creative. I mean, I think most of the people in this room are probably engineers of one sort or another. You have to solve problems. And the vendors will solve, most of the problem for you, but it's that 20%, it's that gap that we care about, because those are the things that slip under the radar, they slip under the door, and they're also the things that are exploitable and that we need to be concerned about. What else? Oh, and I mentioned a second ago, well, now we've got SBOMs mandated and everyone's got an SBOM, but supply chain attacks are increasing. So why is that? And primarily, I'll skip to the end here, primarily because SBOMs just simply aren't sufficient. I'm not saying they're bad, and I'm not saying they're not necessary. They are necessary, and they are a good thing to have. And what's even better is one that you can trust, and one with high fidelity, which is to say that it shows you not just what your package manager tells you have, but what you genuinely have. Those aren't necessarily the same thing. So, and well, I'll talk about it now. I don't do my slides in order. So if your package manager tells you that you've got Xerxes or something like that in it, and your source composition analysis tool says, oh, he's got Xerxes 1.2. I'm not actually sure if that's a version. But the package manager will just intrinsically trust that. And not all SCAs, by the way, work the same way. So there's a caveat that there are all kinds of SCA tools, and they all work differently, but most of them work this way. They read your package manager, assuming that you're not coding in C or C++, that's a different story. They read your package manager tells you exactly what's in there. So it's not a difficult job, right? It may not tell you what the transitive dependencies are. That's where some of the magic comes in. And it won't tell you necessarily about some reachability or runtime analysis. That's a good thing to have, but it's has been somewhat difficult to achieve, although some people claim to have done it, and they probably have. But what it's actually doing is, so you get your component, you get your version, it goes to the NVD, and it goes, and other sources. Nobody just looks at the NVD these days. It goes to the NVD and other sources, and it says, these are the vulnerabilities we know about, we'll report them. It tells you what your licensing obligations are, and that's kind of it. Oh, and it'll tell you quality now also, because most of these tools handle quality, which is a really super useful thing, which I think has been ignored. So, but you've got all that, but at the end of the day, you're reading the package manager, and if the package manager is wrong, or I wouldn't say if the package manager is wrong, if the package manager says one thing, and you go out to a repo and say there's a typo, and there's typo squatting, maybe the repo you've gone to has been poisoned, maybe it's been repo jacked, which is to say someone's taken over the repo, and that's happened. It's happening more frequently, and it has happened. And if I go to NPM or if I go to GitHub, it's actually harder to do with GitHub, by the way. But if let's say NPM is considered to be the most isolated of repos, if you go to NPM and you pull a package, but somebody has taken over that repo, which is not the hardest thing in the world to do, then you've actually pulled, as a user, you think you've done the right thing. You've pulled the package, the SCA tool thinks it's done the right thing, and you've downloaded malware because some bad actor has decided, that this is an easy exploit. Let's see if I manage. So I like to talk about the good things and the bad things about regulations. So there are a lot of regulated industries, the airline industry, the automotive industry, the FTA. By the way, if these notes are available, the reference is over here. And this was a great article. So I was asking myself, because one of the things I see is I hear a lot of people go, well, we need to do this, because it's regulated. And well, why is it regulated? It's regulated because it's supposed to improve our security. And if it's not improving our security, it's not doing anything. It actually is doing something. If you've got a regulation and you're not improving your security, what you're doing is you're unimproving your security. That's probably not the right word to use. But you're paying people to spend time and effort, and you're spending your company's money on a resource that is kind of detracting from money that can be spent on real security. I'm not saying regulations are bad. I have my glasses. So I'm going to kind of try and summarize this here because I took some notes. Let's see, here we go. So the first thing they kind of say is compliance is an accountability enabler, which is a good thing, right? It's good to know who's responsible for what. B, cybersecurity compliance differs in different industries. The bare minimum offered by safety rules can be acceptable to be compliant. Not necessarily a good thing, right? When we're talking about bare minimum. But here's the meat of it. They argue that much of the mandatory controls required by regulations may negatively drive cybersecurity behaviors. And that's kind of the meat of that there. And I highly recommend reading this if you work in a regulated industry. Bring it to people's attention if you want to be unpopular, because that's what'll happen. Again, this came. I was just sitting around going, I find regulations can be a good thing, but not if they're tick the box. So one of the things I do for work is I ask people, have you done your SAST scan? Have you looked at the results? You'd be surprised at how many people actually run tools and don't look at the results. Here's my favorite though. When it comes to SBOMs, inbound SBOMs. So I've got a vendor, and we're using their tool. Maybe we're delivering some of it as part of one of our products. I request an SBOM from them, and we get the SBOM, and then we stick it in a file and never look at it. And I have found, not just in my industry, for many people, many industries, they're grabbing these SBOMs and they don't even look at them. Some of them are Word documents, some of them are Excel documents, some of them are JSON documents, but if you run them through, dependency track or something else like that, it'll show you that, it's not formatted correctly and you can't do anything with them. But often, nobody looks at them at all. So that's my little spiel about regulations. I've got more to say about that a little bit later. But it does detract. Let's see if I can get this right. Got it. Oops. Good enough. All this stuff was in the news in the last year. Give me a second to take a look at it. I do have attribution at the bottom if you want to read the articles. And I do think that all of these are going to be available online somewhere. I don't know. But It is Repo Jacking we'll be talking about. Docker Hub is the scariest one here, I think, because if you want to talk about trust, there's two scary things here. Docker Hub and xzutils. Those are really frightening because, Docker Hub, does anyone not use Docker? Everyone uses Docker. Even if you don't think you're using Docker, you're using Docker, pretty much. It's the way, and it's convenient is why everyone uses it. If I want to ship a product, forget about all the installs and all this, and worrying about dependencies, worrying about if it'll work on the operating system, all this and that, forget about it. Docker handles all that for you. So it's ripe for corruption. It's ripe for exploitation. It's ripe for vulnerabilities. It's ripe for attacks, which makes this a huge concern. xzutils, I got a whole slide on that one. xzutils is kind of like zlib, right? Even my refrigerator uses zlib. It's a compression utility. And that's actually not a joke. My refrigerator probably does use, there was a survey of things that use zlib, and apparently it's literally in everything, including apples. I walked too far away from my thing, hang on. Oopsie, there we go. So, I'm not gonna really talk about SolarWinds because it's too easy to beat up on them. And they were kind of the victim, and then there was a whole bunch of lawsuits, and there was some question as to whether they were lying about their compliance, and whether they were I'll say the CISO. This lawsuit, by the way, made becoming a CISO a scary thing because if you followed the lawsuit, and I'll see if I can remember. I love following lawsuits. If you followed the lawsuit, basically what happened was the CISO went to the board, he went to the CEO, and he said, our security is great. We're doing all the right things. We've got all the, people like to use the word controls. I don't like that word, but it's everyone uses it. If you study for the CISP, I think the word controls is on every single page. He said all those things, and of course, then they were hacked. Now, the hack was a very sophisticated hack, and it was like it was a nation-state hack. If you allegedly by Russia, if you look at nation-state hacks, there's almost no defense against them. So I can't blame them from that. But there's two things that happen after a hack. Well, basically one massive thing. And that is accountability and response. Oh, it was two. So accountability and response. You have to get up front, and the longer you allow these things to get behind you, the more people can be affected negatively. I'm going to check for my own time. It would help if I could read my watch. So they did let quite a bit of time, go by. Now there's an SEC, ruling which states that I think you've got 48 hours or something like that from knowing about something to having to report it. If you're a public company, if you're not a public company, you can do whatever you want. So he was so the CISO was sued, and then it turns out they dropped the lawsuit, so who knows what happened after that. But this is all kind of about trust, though. And we trust our repos to deliver libraries. We trust the OS patches to update our platforms, vendor updates, right, and feature updates. We trust all these things. But as Ronald Reagan once said many times, apparently, trust but verify. And we add the and verify, because you simply can't emphasize verification enough. And that's kind of what security is going to be about today and in the near future is everything you grab, and this was what SBOMs are supposed to be about, everything you grab that you didn't write has to be verified. Let's see. Oh, I just created a slide because I really liked this title. There's really nothing to say about it other than I thought it was kind of fun. So different types of repos. These are the older ones. So, Pippi, or Pipe, I don't know how to pronounce it. There's been a lot of hacks on Pippi. The hack being all the sort of injection type things where someone, takes, I'll give an example of it shortly, where someone, takes a repo, puts in, typo squatting, or takes over the repo, or so on and so forth. I think I have some statistics on that. Let's see, what slide am I on? I don't know. Where are my? Okay, I can't find my numbers. But basically, when you download one top level dependency, I'll do this off the top of my head, and see, I'm probably going to get it wrong. You're downloading something like about 34 transitive dependencies on the whole, if you're looking at, I think it was either Python or NPM, it's one of those two. So, you're downloading 34 like requests underneath that. The first thing you're going to see is URL lib, right? That's the first thing that you pull under that. And that pulls in something like 20 other things. So your dependencies and your transitive dependencies, you don't have good insight into them. And anything you don't have a good insight into is basically the way to attack you. So the danger isn't in the things you know, it's in all the things you don't know. And you don't know what URL lib is pulling in. If you look at your package manager, it's not even going to mention URL lib. It's just going to say requests, and it's going to have a version, maybe a version range, which is even worse. And we'll get into why that is. And one of my favorite attacks, dependency confusion, because I spent a lot of time working on that one. I spent a lot of time, we spent a lot of time actually, mitigating dependency confusions at another company. It's a huge deal. The Department of Irony. I don't know where I get these things from. So let's see when I have something here. Oh, yeah. I'm just going to read this. This was in the news. South Korea's National Cybersecurity Center warns that state-backed DPRK, which is North Korea, hackers hijacked flaws in a VPN's software update to deploy malware and breach networks. VPN's the thing to think about there. It breached a VPN, right? If you can breach a VPN, that's kind of the ultimate supply side attack. That's just like saying, of course, it's not an application supply side attack, but we're allowed to talk about things other than application, attacks. It's the ultimate attack in a sense that you've basically just said, come on in, do whatever you want. And let's see, a top digital security firm learned a remote employee was a North Korean hacker. That's not good. The North Korean linked threat actor known as Moonstone Sleet, I don't know where they come up with these names, has continued to push malicious NPM packages to the JavaScript package registry with the aim of infecting Windows systems. So, you get one of the articles here. But, this is just a different example. Now, how do you sort of defend yourself against this type of attack? It's not a repo attack. It's an endpoint attack. So this is where your cloud security people would come into play. And despite the fact that almost everyone has endpoint security software, they were still able to get through. I don't know how they did it, But again, if it's a state-sponsored threat actor, there's very little you can do about it except for continuous monitoring. And the use of, and I'm going to say that, the C word, controls, which may or may not help. Oh yeah, let's see. I mentioned, I didn't know how bad these lines looked. Oh, they're pretty straight. There we go. I mentioned there's more than one type of supply chain attacks. These are some of them, there are more. But dependency confusion, which we can talk about, because I got a lot on that. Repo jacking, typo squatting, repo poisoning. And I will add to that, your basic continuous integration type tools and mechanisms, such as Jenkins. And one thing about Jenkins is open source. If someone can, if you can manage to submit code to Jenkins and you get a successful pull request, then you've infiltrated Jenkins. And there's some really clever ways to hide malware in seemingly innocent, code submissions. And some of them are like using different types of, one of them, a lot of them involve like using hashes, or a lot of them involve, doing the, the 64, 32-bit encrypt, or whatever it is. But it's all readable. It's all human readable. It's not real encryption. But it's character encoding. Character encoding is what I meant to say. So it's character encoding, and you can do a lot with character encoding when it comes to, modifying your code so that it's hard to read, and you can definitely put some malware into that. So we'll be talking about all these attacks. I completely stole this picture, by the way. Dependency confusion. I've got this here, and I've read this article like 5 times. This article is by the guy who he was a researcher, and he started thinking about ways that you can hack different companies through repos, and this was a really interesting one. And it turns out to be not easy to defend against, but it is defensible. So basically, what happens here? Oh, I wrote it down. Confusion attacks, private software dependencies. What happens is, if I've got a component, if my company, the XYZ company, has a component, and that component is called A, and it's version 1.0, and it's a private component, which is say I wrote it, didn't go get it from a repo or anything like that, and I go try and load that from a package manager like pom.xml file or something like that. And I go try to pull that, and some clever person went into, Maven or whatever, and they put in whatever the example I used was, 1.2 or 2.0 or whatever. A lot of package managers are going to go pull the higher version automatically, and so this person who's this researcher used that technique to basically hack into Apple and all kinds of companies. He's an ethical hacker. He told them about it. He told them he was going to do it, or that he did it, and there was nothing they could do to defend against it at the time, because it was kind of a newly reported attack. But anyways, I highly suggest you go read that article, and we'll talk a little bit more about that. So this is what it looks like. Dependency value, the value is the highest, right, in this case. So I'm just going to say you don't want to do that. It seems like a good idea, right, because everyone says you don't want your dependencies to be out of date. Older dependencies are more likely to have vulnerabilities. So what do you do about that? Well, you grab the latest one, right? But if you grab the latest one, you may be grabbing malware. And in fact, you don't know what the latest one is. There's all kinds of ways that could be compromised. So don't do that. Here's some, You know, I think I said that I was going to give some practical guidelines on, you know, how not to mess up, how not to be a victim. Reserve the package name in the registry. Specify the version in the package manager. Validate checksums is a big one. There's a whole article by JFrog which sells Artifactory. Artifactory is a binary repo. A lot of companies use Artifactory because they don't want to. They want to be able to build and have their components, their binary components in one place. It's not meant to be a source repo, but people use it for that as well. But you can configure Artifactory so that if there's a virtual repo which goes, oh, I'll get locally, but in case there's something better, I'll go out, something newer, I'll go out to the web and I'll grab it. You can configure Artifactory so it won't do that. If you're not doing that and you're using Artifactory, you need to do it. You need to understand what the problem is and you need to fix it. And the fix is described, I believe it is described in this article here. So if anyone hasn't read this article, assuming that it's relevant to you, read it, because it'll help you defend against your that type of specific attack. I wish I could make these bigger, the right size. The XC compression utility. I wasn't going to talk about this, but I just love this picture. So the XC utility. This one was this one almost took over the world. If this had gotten out, I think chaos would have ensued, because after like zlib, and I'm just totally making this up by the way, XC is probably one of the most commonly found libraries in all code. It's been around forever. It's distributed with almost every version of Linux, if not every version of Linux. Okay, so I should also mention that it's an open source project, as are many of the kernel things and Linuxy type things, and that it was, if any of you have seen the picture of where you've got this kind of architecture, and it's all this big complicated architecture, and on one side there's this little stilt, and it says, some component maintained by some guy in Nebraska or something like that. That's kind of what XZ is like. It was maintained by a single person. Anyone who's ever created a repo that other people use, for open source, I have, and I stopped maintaining it almost immediately because I'm lazy, and I don't get paid to do it. Most open source, most open source people who are creating components, it's not a full-time job. You don't make money at it, and if you want to do really well at the job you're getting paid for, you may not be able to spend all that time when it comes to maintaining your repo. And in this case, I believe the maintainer was badgered by the bad actor, and so the bad actor is like, you're really doing an awful job. You should step down. You're way behind on your pull requests. You're a jerk and your feet smell. Basically, and the guy became despondent, and he's like, hey, listen, I'm a volunteer. I don't get paid for this. It did get, so the way it was discovered, by the way, it was just fortuitous. Well, I wouldn't say, it was a guy named Andre Freund, I believe he worked for Microsoft, and he was looking at Valgrind, which Valgrind is a kind of debugger, tells you how much memory you're using. If you start an application and you've got, 1 gig, and then you close that application and you've got 0.9 gigs, there's a problem. That's kind of what that person was seeing. Where's the memory going? He traced it to XZ, and then realized, holy shit, we've got a really serious issue here. And he pulled the plug on that, and we're all very fortunate that he did. Okay, this is the picture. These pictures I'm going to get sued for because I did not pay Toho Films. I actually tried to figure out how to pay them, but I couldn't. So don't anyone tell anyone. Repo Jacking and Repo Poisoning. The Repo Jacking and Repo Poisoning are kind of similar, but not. So Repo Jacking is, the case I just mentioned with XZ, where somebody goes and manages to take over the repo. There's a lot of ways you can do that, by the way. GitHub has made it harder. I'm not sure about, so GitHub is actually, they got more people. And they got paid people. Not all the repos have paid people. So anyways, you can take it over, and then you can do whatever you want, And there's some recent instances of it. One of them is color, and that was just some commonly used. I think it was a JavaScript package, and people were downloading that. And turns out someone had taken it over, and I don't think it was very nefarious. I think he was just like angry at something or someone. But so there's actually two. If you're talking about guarding against these kinds of things, there's two aspects to it. One is if you own the repo, or it's a URL, you own, or a project you own, there's one way to guard against it. And if you're consuming it, there's another way to guard against it. If you're two-factor authentication for most things, if you got a repo like GitHub, I don't know if GitHub requires two-factor. It does now? Yeah. Okay, so GitHub requires it, but not all the repos do. Who doesn't require two-factor authentication a lot of times? It's not a repo. It's a kind of repo, the banks. I actually spoke to security engineer. He was actually like director of security engineering at a big American bank. And we were talking about security. And I said, well, why don't you require two-factor authentication? And he said, people won't do it. We can't get most people to use two-factor authentication. So I don't know what the solution to that is. Some people talk about FIDO2, which is passwordless authentication, but that requires anything that requires walking down the stairs. If you got to go to the bathroom and you got to walk down the stairs, you might think twice about it. If it's right there, so the easier a security control is, the more likely it's going to be used. If it's hard to use, you won't use it. Let's see, how am I doing for time? How am I doing for time?
You've got 7 minutes.
7 minutes? Oh, shit. Let's go. Let's move on. OpenSSF score. That's good for GitHub. Use it. It's really super cool if you haven't tried it. It's good for quality. Pip install request. See how clever that is? Good defense is a good defense. Just a good example of typo squatting here. Typo squatting, if you own a domain, register all the domains that are similar to it. Let's see. I just said that. Two-factor authentication. It's the mantra of the day. If you can do this, review when you pull. It's a super. One thing you could ask your developers to do is request it, fill out an application, say, can I use it? Then ask them where they're pulling it from, and then take a look at that source and see if it fulfills the quality. First of all, you don't want abandonware and this and that. Use scoped packages. You can use that in NPM. I'm not sure what else you can use in it, but if you can use a scoped package, you can defeat typo squatting. So I recommend that. Why SBOMs don't help? I'm not going to say that they don't help at all, and it's misleading. So I apologize. I should have changed the name of the slide. Why they don't help as much as we would like them to. I love this picture. I stole it. But it kind of says it all. If I ask my vendor for a software bill of materials, and they say, here it is, and then I do something that nobody does, and I check it, and I look for the vulnerabilities, and I look for the licensing obligations, and I'm super happy because I've done my due diligence, but it turns out that the vendor, they didn't do theirs. And it might not be intentional, it's probably not. But if they don't do their due diligence, if they don't capture the transitive dependencies that you will be running if you use their product, you're in trouble. Let's see. Oh, they satisfy regulatory requirements, which is something I mentioned earlier. You know, I've seen a lot, not just where I am, but in more than one company now, where people say, we've got our SBOM tick. Not good. You're just asking for trouble. Don't allow that to happen. I'm almost not going to have time to talk about Omnivore and reproducible builds. Omnivore is an open source project that I work on with a lot of people who are smarter than me. Some of them might be not here in the room, but at the conference. And Omnivore is a way for creating reproducible builds. And basically, it's a way of creating a graph. You look at, what we look at is the runtime. So a lot of people might have heard of Deep Factor. They did runtime analysis. Runtime's pretty cool. They were just purchased by Cisco, so you can't buy their product directly anymore. But runtime tells you what you're actually using as opposed to what you think you're using. And if you can do runtime analysis, you're not going to have any false positives. So let's see, because I didn't realize I was so far behind. I was worried I wasn't going to be able to, I was worried I was going to have too much time. So let's see, what else is there? You should go to the Omnivore website. I wrote some of the Python code, which explains why it's really awful. You know, what I do is, and I have to change it, by the way, but basically, if you run a Python, I use it as a target. I look at what it pulls in at runtime. I tell you what it pulled in, where it pulled in, what the hash is, and you can build a graph off of that. And if you do that once, and you can do a lot of stuff with that, you can embed that, that manifest somewhere, and you know, if you can't reproduce it, it's not what you thought it was. A lot of these things are just because I like the picture. This is the death of Socrates, and it is relevant. And why is it relevant? One, because I use what's known as a Socratic dialogue, which is a question and answer way of you know, forming a philosophical argument. The other, because he's drinking poison, that's hemlock, and so kind of fit some repo poisoning in there. The other is that he's doing it calmly. Everyone else, as somebody commented on my LinkedIn page, is freaking out. Security tools will solve your problem, right? No. Why not? Security and engineering is all about the edge cases. And this is kind of where I was building up to, so I might get 2 more minutes, hopefully. Okay, so security is all about the gaps. The gaps are the problems we really need to solve. And security vendors, who are some, and I love these guys, by the way, everyone here, but there's a financial incentive to address 80% of the problem, and that 20% is your real problem. And that 20% is what's going to cause you to fail as an organization. Open source is your friend. A lot of ways to close gaps. If you've got a gap, and we have a gap, a lot of people, C++, biggest gap. Transitive dependencies, second biggest gap, or maybe the first biggest gap, depending on what kind of an organization you are. These are problems that you're going to have to solve yourself sometimes, and there's a lot of ways to do it. Look to the open source world to find that. Yeah, this is my pessimism here. Mind the gaps. Not all aphorisms I wrote after 3 beers. Not all risks can be eliminated. No risk can be completely eliminated. Depending on how much risk you can assume as a business decision, one smart, curious, and hardworking person is worth 100 tools. And that's it. I got that.